Welcome everybody. I'm very pleased to be here at the Docs Toronto. I've been a lot here, but this is my first as a speaker, which is apparently a side effect if you hang out a lot with them. Today our topic is what makes OIDC so cool you couldn't afford not to use it in your GitHub pipelines. But before talking about that, I would like to share talk about context and share a small culture clash I had when I moved in Canada from Europe. So basically, corporate communication back in Europe is more about laying out the details and the history and the theories, like explaining why they choose one option over zillion others, with details, etc. In a mighty email. So it can get super big, but they got time, and it usually works. First I got here, I thought I would do the same. So I just kept sending those long ass emails to my managers, because I thought it was right, because it made sense for me. But the only feedback I got at the end was, we don't want to hear your long stories and boring stories. Just tell me if it's done or not. So okay, so they got me here because I thought giving more context made sense. But at the end of the day, stakeholders just want to know if the job is done or not, right? But here's the thing. Have you ever found yourself in on call on a P1 nasty incident where there's an outage and like you're just busy scrolling emails, looking for that info that could help your day, and then wondering like what happened the last 6 months? But at the end, all you find is emails with replies like job's done, task complete, or bug fixed, or see you Monday. That can happen too. So all I'm saying is, maybe pragmatism is solves today's problem, but context will actually solve tomorrow's problem, and maybe your ass while at it. So this is exactly why I decided, instead of talking about OIDC just like that, coming out of the blue, I decided to actually give context and go back, rewind a little bit the story, go back to the origin story of authentication, and hopefully I will end that within 20 minutes, which is a big challenge for me. But anyway, so yeah, now I forgot my pointers. So that's why I'll be coming back a lot here. Go. Okay, click. Okay, so my name is Kosseila. I'm a solutions architect at Eclipsys. Over a decade of experience in IT and Oracle. I'm also a board of another user group called Toronto Oracle User Group. I'm a tech and DevOps enthusiast, obviously. But all you need to care about, actually, so I don't like talking about myself, is that you can find me. My handle is BrokeDBA, so you can find me in on my website BrokeDBA, or on LinkedIn BrokeDBA. I also have the GitHub where all the workflows I'm sharing in this presentation is available. And I happen to have launched a podcast not so long ago, which I'm very excited about. There's also already, that's the QR code, so you can tune in. We talked about open source. Sorry again, you work for IBM, but Red Hat did some shenanigans lately, but I'm not going to tell more. But you'll learn more on that podcast anyway. Sorry again, buddy. Anyway, so now that we've done the intro part, let's start with a meme, because I like memes. Everybody does, until it does make sense. But anyway, this meme is for situations where we know that we have different expectations when we decide to use CI/CD to deploy in the cloud, right? Some people will go all in, others, like our friend Anakin here, not so much. It can happen. But the good thing is, even though like we know that deploying to the cloud doesn't make us security savvy by default, right? So you're not supposed to know all the best practices. But the good thing is that it's never too late, right? You can start with something and then you hear about a better way, safest way to do it. And then you can just read documentation or blogs or hear about it and you apply it. So it's actually never too late, right? So what are we talking about today? First, I just want to let you know that there is a long version of this presentation in my blog. So we can scan the QR code. It has way more details, all right? Because in 20 minutes, there's only so much you can do. But basically, first, we're just going to talk about the popular authentication in the cloud and why the current state is wrong, or at least like the basic way of connecting is wrong. And then in the second section, we'll go back to the Stone Age and know like the origins of the authentication before OAuth was there. That's why I put context there, just so you see it. And also the terminology, the workflow, how it works, because it's very confusing sometimes for these concepts to be understood and even worse to explain, right? So I took some time, many weeks to understand first before applying. So it's always easy to apply, but it's harder to explain to someone else, the how or the why. And then, so terminology, workflow, then the third section is about OIDC and what OIDC is bringing on top of OAuth, because it's not an overtake, it's just, it sits on top of OAuth. And we'll talk about what is different in the workflow of OIDC. And the last section we'll deep dive into OIDC and how it is used in GitHub Actions. And also see multiple scenarios, type of authentication, whether you deploy to Azure, AWS, or GCP. Because I already got workflows where like you can deploy a VPC through OIDC. Right. And then at the end, Q&A, if we have time. Okay, so first, yeah, so she talked about hackers. Earlier you talked about hackers. I just want to draw your attention on a recent report by I forgot the name of the company. It's Guardian Git. Yeah, Guardian Git. And all you need to remember is that like just in 2022, we had 10 million credentials from GitHub that were exposed, right? And you got 3 million unique, of course, but still 10 million. And this is all like the whole shebang, not like small companies and SMEs. You got companies like Uber, Samsung, Toyota, NVIDIA, even Okta, which are supposed to work on, security, authentication. Even them, they got some secrets in GitHub. So this is very serious. This can be like a big threat for your company having, it's for example, you can see here 5 out of every 1,000 commit had secret exposed in GitHub. We like, it depends. Like it could be companies, it could be states, it could be organization. That's 5 out of 1,000 commits with secrets. This is how bad it is right now. Next. Well, the popular authentication to cloud for now is, for example, user or workload principles. Some of them are static, some of them are dynamic. So the static ones are like user-based, like the interactive login for GCP and Azure, or using access keys for AWS. You got service principles, using key files or password for Azure. And you got dynamic ones, which use instances, right? So like it's more a workload, not a person, not a user, right? But if you want to use that for GitHub Actions, for example, you would need your runner to be actually in the cloud, right? In order to be authenticated this way, but which is not always something you can afford. And you got assume roles. I'm talking here for cases where you need to use HashiCorp Vault. That's semi-dynamic. It's still a long-lived secret. So why is it wrong? Why are these standard traditional way of connecting is wrong? Well, basically because short-lived is good and long-lived server, like static credentials, they never expired, right? So if it never expired, that would actually increase the surface of vulnerability, right? In case of leaks. So that means like you could never, when someone has it, you have a lot of things to do in order to get rid of that. You got to know which secret was stolen, and then you got to make sure it's taken off. And you also have managed overhead, where you have to sort of duplicate the storage rotation, which can be a lot for ops teams to manage. If you have secrets that you move between different platforms, you have instance principles. As I said, if you have self-hosted runners, let's say you got GCP, Azure, and AWS, would you have like one instance in each of these clouds in order to deploy from GitHub Actions? That's just an overkill. It's like you cannot do that. That's not sustainable. And even dynamic secrets in HashiCorp Vault, you'd actually require static credentials first in order to enable the secret engines. So it's still not as, even dynamic is not something that will cut it. Anyway, so the context that I talked about, when we go back to Stone Age, right? Back in the days, who remembers Farmville in Facebook? Yeah, for those that are, old enough, okay, that's cool. This is Farmville 2, by the way. Anyway, so back in the days, in order to play with Farmville in Facebook, you needed to put your email and password, right? That means that you not only give the access in order to play once, but they can keep the password and email forever, right? You give the password, and then they can do whatever they want, right? Picture this, it's like giving a key of your apartment to a shady dude, so they like and hope they won't throw like a wild party with friends and make copies of the keys and then steal your stuff like that. That's actually, it's Airbnb. Anyway, but it's still insane. It's actually insane. This is insane, right? Why? Because there are risks that come with it. It's just crazy. I need to play, but then I give my password, and after that, what would I have? I would have impersonations problem. I would have phishing attacks. I would have the application that would have full access onto your account. And for example, back in the days, a lot of application Facebook used to write things on your wall, text your friends, add your friends, and maybe like a weird post in your wall where like you have to tell your friends, I've been hacked this week, by the way, don't read my post, right? This is exactly what happened back then. All right, that's why that's exactly what OAuth 2 came, or OAuth more or less, came to solve, actually, because the question was how to let third-party applications access user data without sharing the password. Well, OAuth is doing that, exactly that. Why? Because OAuth, you won't need the password sharing anymore. There's no need to do that. It allows granular access levels through scopes, and also it receives an access key that is temporary. This is short-lived access key. That's actually the big asset in this technique. And also it's a delegated access. So delegation is the process in which an owner authorized service provider to act on its behalf, to perform actions on the owner's behalf. So OAuth is more fixing the problem of delegating access without using password. For example, Google went even further. Why? Because Google actually have different services, different applications, Mail, Gmail, YouTube, etc. But instead of actually dealing with the access in each of these applications, they actually moved that part of the authentication where like any of the services are not trusted. So they put OAuth in one side, and every time you need to connect, for example, to Gmail, you're not actually connecting to Gmail, you're connecting to accountsgoogle.com. That's the OAuth part. And then you authenticate, then you can go back to Gmail. That means that even within Google apps, they don't trust them to manage the authentication. They go to their OAuth Authorization Server and then get all the authentication done through that. Right, in terms of terminology. So like we heard about OAuth, what is this? It's like something that just came out of the blue. But in the meantime, in terms of terminology, what you need to know first is the actors, right, in the workflow. In the workflow, we have 4 main actors or roles. First one is you, the resource owner, or whoever owns the identity. And then you got the client or the application. This is the application. This is like the new version of Farmville, right? So it wants to have access to your resources, but it will do it on your behalf. And then you got the authorization server. This is where the authentication is done, is checked, refused, or accepted, right? And the last one is the resource server. Basically, this is just the API, right? If it's a cloud provider, if it's your Gmail account, if it's your Facebook, if it's your Twitter, that's actually API server, right? So we got these 4 actors, 4 roles, and OAuth is actually requiring all these actors to make the workflow work. And sometimes you get platforms where you have an authorization and resource server in the same location, and sometimes not. Why? Because they would just delegate that part to Okta. You can have a server, authorization server in Okta, and you have your API server in your platform. And sometimes it happens that like this, you don't have to have them all in one location. All right, in terms of clients, we talked about application. We got 2 types of applications. You got confidential clients, and we have public clients. So the confidential clients are just clients where you have a sort of a connection or relationship with the server that is, its access is server to server. So you have .NET, you have Java, it's running on a server. Every time it communicates with the authorization server, it's secured link, right? And it has the ability to keep secret. The public ones are all the applications that run in single page applications like JavaScript or in a browser or a mobile app. So these applications are lightweight, but there's a difference between these two. Confidential means that you can put some secrets inside. So it's secure to share a secret between this application and authorization server. While with the public client, it's not. Why? Because imagine you have a JavaScript SPA application and there's a secret inside, then you can like just click view source and you see the secret. So that's not a good way to do it, right? So the secret is not used, is not actually put in those applications, not even in a mobile app, but the secret will be shared differently, in a different way. But when it's with the confidential clients, secrets can be exchanged safely. This is why the channel for the confidential client is called the back channel, and the front channel is for the public client. So anything that flows through the front channel doesn't have any secret. Anything that flows through the back channel contains access tokens, for example. Right, but before you get to have that kind of relationship, you need to take care of the trust. So you need to do the application registration. On day 1, you would need to register your application. You can see on the right side, you can put the application name. Those are like just information. But the most important here, when you register an application with the authorization server, is the redirect. Redirect URI or callback URI is just a URL that you need to redirect the owner after consent. It's usually the application. So this is what you need to give to the authorization server about your application. But then the authorization server would give you 2 things, the client ID and the client secret, right? The client ID is something that would identify the client with the auth server. This can go through the front channel because it's not sensitive. And you get also the client secret. The client secret is the password given between the client and the authorization server. And this is like, these 2 are the only ones that have that password. In terms of the rest of the terminology, we got the scope, that's the permission, the grant type. You got a lot of grant type, but usually it's authorization code. So this is the kind of code that the client is expecting during the exchange for, in order to get the access token. You got the consent from the owner, to let the client to act on his behalf. The authorization code, as I said, it's just a grant code that the client exchanges with the authorization server to get the access token, and you got the state. So the state is important because the client sometimes you need to make sure that the authorization server is sending back the information that it was not intercepted. That means that like when the authorization server sends an access token, for example, wherever, the client still needs to make sure that it's legit, that it's really coming from the authorization server. And you got the access token, which is, you know, the holy grail. You know, you want to use the resources. That's the short-lived key that could even be refreshed from the authorization server. This is the kind of payload that the application sends to the authorization server. So you can see here we got the grant type, that's the authorization code. We got the code, and then we got the client secret. This happens when actually the client is asking the access token, right? I'll explain the workflow later, but when this happens, this is a previous step before getting the access token. So we send this to the authorization server checks the grant type, checks the client ID and secret. Obviously, this is back channel. You got the code, and then the access token is given back. So at the end, you get the short lived, because you see here that we got expires in, you got the access token, the token type is bearer. This is what is given back at the end to the client. If you want to play with this, there's a link here called at OAuth.com. They have a playground where you can like simulate OIDC, OAuth, any type of authentication workflow if you want. And now if you want to just show you how it works, just this is a workflow for OAuth 2. We got the client. We talked about the actors earlier. So we got the client, the resource server, the owner, the authorization server, right? So what happens? My application is Yelp.com, right? I log in and it asks me to log in through Google. What happens? The first payload is sent to the authorization server. We got the redirect URL. The response type is code. The scope is profile context, because this is the resource I want to have access to. The state is coming, that's the random value from the client. We got the client ID. This is front channel. Front channel, that means no secrets, right? After this, authorization server receives the request and then shows the accounts google.com to the user in order to grant or give the consent from the owner. So the owner will give the consent, and after that, it will be, if it's yes, then you'd have a redirect. So it will be redirected back to the client, and after with the authorization code. So first we ask for the authorization code with that payload, and now we have it because the client just consented. And after that, we send back the whole content. That's the payload I showed you earlier. The code, the client ID, client secret. Obviously, this is back channel, right? Because there's a secret inside. And once the authorization server checks the code, client ID, checks that it's the same, you know, after that, it gives back the access token. Once the access token is given, then you got the client that can do wherever they want. Like they can get the resource of the resource owner. And that's the last payload I showed you. That's like the authorization access token, which is short-lived. And they can have access to the resources in place, context.google.com. Now, OIDC. So I talk about the story behind, this is all to get here, because usually in videos or in content online, they just don't tell you about OIDC, but they don't tell you how OAuth works, right? So that's why I decided to put that previous step. But OpenID Connect just takes care of the authentication. So it just sits on top of OAuth, right? So it's not an overtake. OAuth is actually, while OAuth provides access delegation, as we said before, via scoped access tokens, OIDC just provides the user the authentication that was needed before. It's like you have an access key. You go to a hotel, you get an access key to a room, but say like somebody takes your access key, it will take the access key and it could still open the room, right? No, like it doesn't have to be the person that actually paid for that room that could get to the room, right? That's why the identification is not there. That's the difference between OAuth only and OAuth with OIDC. as displayed here, OAuth is all about giving the application a way to make an API request, accessing APIs, and OpenID tells the application about the user, like ID, email, name, etc. Like you will know who or like which identity actually try to have access. The difference that, or what OIDC brings is usually the user info input, as I said. So ID, name, email, all that stuff. So we know like who is trying to access, which is important when you're in the cloud because sometimes you make a match with the workload identity. Then you got a new format, a token that has a format called the JSON Web Token. People call it JOT. And I don't know why, but it's just readable. It's readable by a client, but this would allow you to have a lot of claims. That's what can allow a cloud provider to actually match those claims with a role or identity, etc. Right? So in OIDC flow, the client requests an ID token along with access token, and I will explain actually just the format of the token. So you got the header, you got the payload, these are the claims, and the signature. And in the payload, you can see here that the claims are just the issuer, the issuer, the expiration, issued time, authentication time, etc. Those information will be used by a cloud provider, for example, in order to make sure like who is connected or like which workflow is connected. All right, OpenID Connect, not so different. The only difference here is that we have a scope that is different. That's OpenID profile, right? The rest is the same. We get to the consent. You redirect for a consent. We give a consent. We send back to the redirect or callback URI with the authorization code. And the difference here is that in the exchange, there's a token ID. So exchange authorization code for access token, token ID. And once you have it, the resource is different here because as I explained, the addition of OpenID is a user info endpoint. So here we have access to that ID. We're not having access to like deploy something. We just wanted to know, for example, here we got profile picture. And this is part of the information, client information. Owner information, sorry. There you go. More or less the same thing, but the benefits here is that it has a seamless authentication with cloud providers, so no more secrets, no more management, whether it's in GitHub or in the cloud, and it enables admins to rely on IAM least privilege. So if you want, you will not give like read the write all, right? You want to specify, for example, in GCP specific project or an Azure resource group, you gotta define like a specific scope, and you would rely on that. You mesh that with the ID, right? So OIDC requires workload identity federation on the provider side, like a resource, I would say like cloud provider side, for example, to maximize security and reduce maintenance, because there's no rotation, no maintenance, because access is short-lived. The app registration, as I said, it's also important here, but with the cloud providers, you need to do an extra effort. So I need to go there, I need to create like a role depending on the cloud provider, and then match that role with the workload identity federate, workload federated identity. That's the way to get that identity with the token ID to be used. So in GitHub Action, you can see here OIDC trust. That's like the registration, but it's the authorization server. So we got authorization server here, roles to be assumed. That's the extra thing that we have here, but it's inside the cloud provider. We have the authorization server and also the resource server as well, the API, right? And in GitHub, anything related to the OIDC token, the ID token, is within GitHub. So there's an OIDC provider within GitHub that will give an ID token to the workflow. So there's first a request, the OIDC provider within GitHub will give the token ID, the Joe that we talked about. And after that, you get the OIDC token and the role to assume, for example, in AWS. And with that, the authorization server will just check, we just check the OIDC token, the claims and the role, and see if that person or this identity exists, if there's a rule that matches, and then gives the access token. And after that, you can, like, the workflow could use the access token with the assumed role and deploy within the Oracle provider, the cloud provider, sorry. I know I work for Oracle. No, I don't. In order to get the Joe token, your ID token, there's an action in GitHub Action. So you can use something called Action OIDC Debugger. So if you're not sure, sometimes you're configuring and like you could not deploy. There's like those famous error 404 or something like that, where like you think you've done it right, but then your cloud provider say, I don't care, screw you. I don't recognize me. You cannot deploy anything. While normally it's, you think you've done the right thing. But the best way to check your claims within your ID token of your workflow is to run this action, so you get everything in here. And you get the audience, the issuer information, the reference, like the branch, the environment, and the subject, which is usually the most important. You get here, like, this is my repo, Broke DBA, Terraform example, and then the environment is GCP Labs, for example, for Google, right? So I could use this and then add it into the matching rules for my identity workload federated identity. Yeah, sorry. Oh, okay. Okay, can we have like a few more minutes, or like you're too hurried to go to the bathroom? We good? We good? Okay, thank you so much. Okay, we're almost done. Why? Because this is Azure example, for example. So here, GitHub ID provider is the external identity provider. So our workflow will request the token, and then the GitHub ID provider will provide an ID token. There's a difference between access and ID, right? And after that, it will send the token a request for the access token to Active Directory. That's our authorization server. And after that, Active Directory will just check if this application workload federated identity exists and it matches the claims within the token ID. And if it's the right one, it will send the access token, right? This is more or less what I said, right? GitHub provider, Joe token, the action within your workflow will just send that ID token and asking for the info. Azure AD verifies the claim, sends back the token, and then you can deploy. The action is called Azure/login, right? And the input parameters, as you can see here in your workflow, is just none of it is secret, right? These are client ID and tenant ID of the principal associated with the federated identity. So you can make it as a secret if you want, but like if anyone has that, it won't be possible to do anything, right? Because it's matched to your workflow ID, right? Your claims, and also this is just the client ID, tenant ID. It's not a secret, right? And then subscription ID, right? And prerequisite, of course, is to set up the OIDC trust, configure that workload identity federation. So you have to do it. And also the permission for the ID token needs to be to write. Why? Because as we said, the payload earlier, when you ask for token access, the post is actually required to, it's not supposed to be a write, but it requires a write anyway. So that you can do that at job level. So you don't have to specify that in the whole workflow, right? And an example, just a small example of this action, as you can see here, you just call the action, you put the input parameters, client ID, tenant ID that were configured previously. And I put them as secret here because my repo is public and I'm a security freak. So I put it as secret, but some people just put them as variable. If it's a private repo, you just need to put them as variables, right? Same thing with subscription ID. This is how it works. So there is no secret here. You don't have to worry. Anytime you have a secret within the deployment, the runtime, it's just like an hour max. You would deploy wherever you have, and at the end of the execution, there is no secret left. There is nothing spilling in your GitHub, and everything is secure and safe. Same thing with AWS, right? Same thing, the token ID token, and then you send the token ID token and the role that's supposed to be assumed by AWS. Step 5 here, you see like AWS will have the token ID, it verifies the claims, and then sends the access token, right? More or less the same thing. Right, here, same thing, we have 3 inputs. We have role to assume, role session name, the default is GitHub action. The role to assume is just the RN of your role that you created that will match that identity workload federated identity for your workflow in GitHub. And but it's not that's not a secret for sure, right? Prerequisites are the same, and in this example, you know, I put variables. It always original role session name because they're super known, so there's nothing to do. But it's always 1 or 3, up to 3 parameters or inputs, and they're not secret at all. That's all you have to do every time you can run it, and it will be different secret and a short-lived secret. Same thing with Google. So I'm not gonna just, it's more or less the same thing. They just call it GCP STS, their authorization server. And they have 2 input parameters. One is workload identity provider, and the other one is service account, which is the email address of the GCP service account that match your identity. Right, that's the example of the full ID. And you got, again, 3 variables, or I use secrets, but it's not a secret anyway. And you got this, there's no secrets spilling, it's totally secure, and you don't have to worry about rotating or checking your repo if there's any secret left. Right, so we don't have time for a demo, but I do have like you do have the QR code for the blog that has everything, and also the GitHub repo has all the workflows. So all you need to do is to clone my repo, which is public, and then if you have any issues with actually the environments, the parameters within the GitHub environment, just let me know. Just reach out to me, and I can give them to you. But it's not a big deal. I did that for GCP, Azure, and AWS, and anybody can do it, because before I didn't even know what OIDC means. So there you go. Thank you everyone.
Yeah. So basically, I have been working like in fintech from last 13 years. And of course, the data security and overall authentication is really, really important for me whenever I'm like into this. No doubt. Thank you very much for overall talk. It's, of course, OAuth and OIDC is much, much better than OAuth. But I have been I want to know your thoughts around SAML, right? Because whenever we have really sensitive data, for example, PII, so I used to prefer SAML over OIDC. OIDC is more of like, in my opinion, it is more of like authenticating like logins and all those things instead of really highest possible security. So just your thoughts, if you can share.
I don't know. Oh, okay. Now it's working. Thank you. Thank you for the question. I know there's like a comparison between SAML and OAuth, especially. But when you hear people from Okta, they will tell you, you know what, SAML is not good because it doesn't do the job. So that's why OAuth is better for you, right? So I cannot actually get in the middle of this because I'll be biased. I'm unbiased. So I cannot tell you which one is better. But as you said, HIPAA and everything, SAML is the right thing to do. for me, according to my experience with OIDC, anything that is not a person, anything that is a workload, especially when you have pipelines, workflows, when you have a runtime, and you got to be specific within your company organization. For example, you have branches with environments, especially in GitHub Actions, special environment, special branch, etc. So you can actually be as granular as you want. And so far, it's been doing the job. And although GCP was the hardest to configure in terms of workload federated identity, I spent like 1 extra week just to understand how to use the rules. But in terms of workloads, I don't know if there's an equivalent for workflows in general, in terms of like type of identity, not like end user. For now, OIDC has been doing a great job so far.